Everyone. Today's lesson is going to be on oxidation reduction reaction. So you may have heard of this type of reaction. For short, you may have seen it as a redox reaction. Okay, so what is a redox reaction? A redox reaction is when there are electrons that are transferred from one reactant to another. So for example, let's say we have this reaction. You take hydrogen gas, H2, you react with fluorine gas, F2, which yields HF, which is hydrogen fluoride. And of course, we have to balance this. There you go. So I know in the past we know this is considered a synthesis reaction where we take one particular element and we react with another element, giving us a compound which is HF hydrogen fluoride. Okay. At the same time, we can determine if it's a redox reaction, in other words, if there are electrons being transferred from one reactant to another. So how do we do that? Okay. So before we look at this, or before we determine if it's a redox reaction, we need to understand some terms. Oxidation means when an atom loses electrons. Reduction means when an atom gains an electron. Okay, just by looking at the reaction here, how do we determine if it's a redox? We need to look at something called their oxidation number. So let me scroll down for you. Yep. So what is an oxidation number? Okay, an oxidation number is, they're based on coefficients with either negative or positive values. So it can range from, positive -1, 2, 3, or even 0. Okay, and with this oxidation number, we can determine the atom's oxidation number. With that, we can determine if it's a redox reaction afterwards. Okay, so in this email, you have this chart or this document that you can print out or you can download. It's best if you have this in front of you while I'm going over how to determine oxidation number. Okay, so let's look at some examples first. So, okay, here we go. And then, okay, so for the first part of the video, I'm going to show you how to determine oxidation numbers. Then after that, we're going to come back to this equation from above to determine if it's a oxidation reduction reaction. Okay, so let's say you have 1 calcium. What is the oxidation number for calcium? First, I'm going to determine what type of substance it is first. Okay, so you have a pure element, monatomic ion, a polyatomic ion, or is it a compound? Okay, so based on this 4, it's going to be a pure element. Okay, and of course, if you look below it, it says oxidation number is 0. So the oxidation number for this is going to be 0 here. Next, let's say you have this Fe, okay, 3 plus. Okay, same thing. First I'm going to determine the type of substance this is. Is it a pure element? No. Is it a monatomic ion? Yes. Why is it a monatomic ion? Because you see there's a charge for this particular atom. So when there's a charge for this atom, we call it an ion. Okay. So the oxidation number is the charge. So since this particular substance has a charge of 3 plus, the oxidation number is going to be +3. Okay, so if it's a positive, you have to make sure you put a positive in front of the number. If it's a charge, then you put the positive or negative after the number. Okay, oxidation numbers and charges are 2 separate things. Okay, if the oxidation number allows us to check later on if something's being oxidized or reduced. Okay, let's look at 3 more examples. Let's see, you have this H2S. Okay, so let's go through the types of substance. Is it a pure element? Nope. Is it a monatomic ion? No. Is it a polyatomic ion? No. Is it a compound? You bet. H2S. Okay, if I ask for the oxidation number for this compound, then it should be 0. However, if I ask for the oxidation number for each atom or element, it's going to be different. So let's go and determine the oxidation number for hydrogen and for sulfur for this compound. Okay. So next thing I want to do is I'm going to look down here. There's this chart at the bottom where it says per atom oxidation number. Okay, so I'm going to go through each one. You're going to find hydrogen, number 5. There we go. It's +1. So the oxidation number for hydrogen in this compound, for one hydrogen, it's going to be +1. Okay. So it's an easy way to remember this. Look at hydrogen. It's in group 1, which means it's going to be +1. Sort of like when you look at the charges in group 1. Okay, next, sulfur. Okay, as you're looking through this, it's not in group 1, not in group 2. It's not fluorine, aluminum, hydrogen, and oxygen. And it's not none of those halides or halogens. So it's actually considered a flexible element. So what does that mean? So it means that sulfur can range from an oxidation number of -3 to +3 and so on. So how do we determine the oxidation number for this particular element in this compound? What you need to do is to set up an algebraic expression to solve for the oxidation number. So let's start with hydrogen first, okay, in this compound. There are 2 hydrogens, and each hydrogen's oxidation number is going to be +1. So I'm going to put a +1 right there. Then I'm going to add it to sulfur. How many sulfurs do you have? 1. And oxidation number for sulfur is going to be X, because that's what I'm trying to determine, the oxidation number for sulfur. Now I'm going to set it equal to 0. Why 0? Because the oxidation number for the compound is going to be 0. Next, I'm going to solve for X. This is 2. This is plus X. I'm going to set it equal to 0. So which means, guess what? X is going to be -2 for the oxidation number for sulfur. Okay, let's look at 2 more examples. Okay, let's try this one. Let's go with Na, sodium sulfite. Okay, so let's take a look. What type of substance is this? It's not a pure element, it's not a monatomic ion, or it's not a polyatomic ion. Again, it has to be a compound. So the oxidation number for this is going to be 0 for the compound. Now, if I ask for the oxidation number for each atom per element, sodium, sulfur, and of course you have oxygen for the last one. Okay, so what I recommend you do, since there's 3 of it, take care of the atoms that you already know, and then the one that's flexible, you want to solve for it at the end. So for example, let's see, first things first, sodium, it's in group 1, so the oxidation number is +1. Okay, oxygen, there we go, number 6, -2. Okay, sulfur, yes, it is flexible. So again, I'm going to set up my algebraic expression to solve for the oxidation number of sulfur. Start with sodium first. You have 2, oxidation number +1 for each sodium. Add it to 1 sulfur times the oxidation number for sulfur is X plus oxygen. You have 3. The oxidation number for each oxygen is -2. I'm going to set it equal to 0. Okay, so let's solve for this. This is 2 plus X -6. We'll set it equal to 0. Okay, so at the end, X is going to be +4. Okay, so sulfur has an oxidation number of +4 in this one. Okay. Notice for sodium sulfite, the oxidation number for sulfur is +4. The one before it, there you go, hydrogen sulfide, it was -2. Okay. Hence, that's why sulfur is considered a flexible element. It can have more than one or one different type of oxidation number. So hence, you have to make sure you set up an algebraic expression. Okay. Okay. One last example. Let's say you just have SO4. This time is 2 minus. Yeah, here we go. So it looks like we have a polyatomic ion, and hopefully you guys remember this is called a sulfate ion. Okay. So what is the oxidation number for this? Let's see. Let's take a look at the rules over here. Okay. So again, we know it's a polyatomic ion. Oxidation number is equal to its charge, just like the rules for the monatomic ion. So what's the oxidation number for sulfates? It's going to be -2. Okay. So next, let's say I ask for the oxidation number for each of the elements. You have sulfur and you have oxygen. Okay. So again, since sulfur is flexible, I'll just take care of that at the end. Oxygen, you can see that a lot. That should be -2. This time, I'm gonna set up my algebraic expression. Same thing, I'm gonna solve for sulfur this time. How many sulfurs do you have? 1. Okay, X is my, represents the oxidation number for sulfur. Add it to, how many oxygen? 4. The oxidation number for one oxygen is -2. I'm gonna set it equal to, not 0 this time, but I have to set it equal to -2, because that is the oxidation number for sulfate ion. Okay, so simplify this. X -8, set it equal to -2. X is going to be +6. So sulfur's oxidation number is +6 in the sulfate ion. Okay, so I want to make sure you understand for now. Just use this chart to help you out to determine the oxidation number. This is something I expect you to memorize for me. So rule of thumb is, how do you memorize this? It's best if you take a look at the elements and figure out which groups it's in, especially if you're looking at a compound or a polyatomic ion. Okay, group 1 +1. Group 2 has the oxidation number of +2. Fluorine or your halogens, halides are going to be -1. Aluminum is group 13, so you're going to know it's +3. Hydrogen is group 1 +1. Oxygen, don't forget, it's in group 16, so just think of it as a charge of -2 or 2 minus. So the oxidation number for oxygen should be -2. You're going to see oxygen and hydrogen a lot as you're going through these types of problems or finding the oxidation numbers. Okay. Okay. So lastly, let's go to the top again.